Hi guys, in today's video we're going to be looking at a physics design challenge that you can set your kids in order to teach them a little bit about forces and the conservation of energy. Now, if they are successful in this lesson, they will have solved the world's energy crisis. Therefore, they're not going to be successful. That's kind of the point of this lesson. They are engaging in an exercise in futility, but it's an instructive one. It's something that has some educational value. So the design challenge for them today is to create a perpetual motion machine. Now, there are loads of different designs that you can use for perpetual motion machines. There's videos of them online, ostensibly working. There's different pictures of them, and they've been around since as long as we've been trying to build things, basically. But they are technically impossible because if it was possible, they would break the laws of physics themselves. Physics has certain immutable laws, and the first law of thermodynamics is the law of conservation of energy, which basically says in this universe you can't create energy and you can't destroy energy. Energy only ever changes form. So a simple perpetual motion machine that you can get them to try to make is basically a funnel connected to a piece of plastic tubing. Very, very simple to make. And what they're going to do is they're going to put in some initial energy by lifting up some water and pouring it into the funnel. And you would expect, and the idea is, that the water, I've actually got a bit of a leak here, it's not perfect design, the water should go all the way around and come back out the top. I really should have got a tray for this. Excuse me a second. Improvisation. So the water should come all the way around, if this was possible. However, in this case it's not actually possible, and so the water won't actually happen. But the interesting point for them to think about is, well, why doesn't that happen? Why can't it just keep going on a continuous loop? Are there any situations where that might be possible? If we put in additional energy at the top here, would we be able to get it started and then keep it going? You can present all sorts of additional questions to them to try and extend their learning here. And it doesn't work, so why doesn't it work? We've put energy into this system, it's gone in the top. Why isn't that enough energy to get it going over this barrier here and back into this? No matter what I try, it's never quite enough to overcome that level there. It always settles back to that level. And basically, what the crux of it is, we just can't get enough energy, or even if we do get enough energy to force it over that hump, it's not then giving enough energy back into the system to keep the loop going. So it's losing energy to gravity and to friction to move up this tube, and so it then can't give enough energy back down to push it round again. That's the idea behind it. It's a fairly simple experiment to do, a fairly simple one to set up with your class, and it makes a couple of valid scientific points that actually give us some insight into the very nature of our universe, which I think is quite nice. Cheers!